15-year-old's room here.
Hey.
Let's get the mass. Oh, look, science stuff. Anyways, we're going to do some physics. I think we should have named the cat Schrodinger.
We should have, but they wouldn't let us.
Okay, we're going to do physics. Something in motion, does it weigh more or less?
I mean, technically it weighs more, right? But, like, really, the point you're driving home is because, you know, technically it'll weigh less. Or the same. I don't know. I'd have to run the math, right? But the point is it could weigh more or it might not. But really the point you're driving home is it has more gravitational influence, right? Because when you have an object in motion, right? Let's just start with this. E equals mc squared, right? Everybody knows that.
Everybody knows this?
Everybody, what?
Okay, what is
This is by far, like, people might not know what it means, but this is by far the equation with the most street cred, right? Of course, E equals mc squared. Energy. Mass. And then C stands for the speed of light, so it's the speed of light squared. So,
what's the speed of light?
Let me put SOL.
What's the speed of light?
Speed of light. The speed of light, I only know it in miles.
Okay, miles.
186,262.2 miles per second. Or is it? It could be 0.3. So this tells you the energy, or the mass to energy conversion rate. If you want to find out how much, how much energy per mass, you would multiply the mass, preferably in kilograms, by c squared to get joules. Or you could, same way you could do mass is equal to energy divided by the speed of light squared. You can derive that, right? So this tells us that, let's say, by this rule, you can actually go, well, as Einstein said, a hot cup of coffee, right? So like a cup of coffee at, say, I don't know, we'll go,
Let's
15 degrees Celsius.
Okay.
Will weigh more than a cup of coffee that's
at 0.
10 degrees Celsius or 0 degrees or whatever you want, 5 degrees, etc. Right? This will weigh more than that. And that's because the molecules are moving around, they have more energy, and thus they have more mass, and thus more gravity influences them more, right? You can actually see this. I remember I asked my college professor, he said, because we brought this up, he said, the faster you're moving through space, the more mass you have. And I said, so, like, does that mean an object moving, a ship moving at 50% of the speed of light has more gravitational pull on the things around it than a ship at rest? And he said, yeah. So that can, of course, be applied to a car on the ground, right? If you have a car, yep, that's a car. And then this one's at rest, and this one is in motion. And if they're the same cars, they might not be the same. This one might actually weigh more or weigh less because the curvature of the Earth and all that. But hypothetically, this has more mass, more gravitational influence, which is essentially more mass, right? That's the point you're trying to drive home here. And then, interestingly enough, I could be wrong about this, but I think I'm right. If you take a boulder of, I don't know, we'll say like 10 kilograms, right? So we know that 10 kilograms, you can calculate the gravitational force between it and any other object. But what I found interesting is if you think of potential energy, which is a form of energy, right? Everybody knows the classic example. If you put this boulder at the top of the hill, it took more energy to get it up there, but that energy was converted into potential energy. So if potential energy is a form of energy at the top of the hill, this boulder actually has more gravitational pull because it has greater potential energy. It's exerting more gravitational force on everything around it
Than the one on the ground.
Yeah, even though they're the same exact mass.
Okay, so let's simplify it a little bit. Something moving has more mass, so therefore it has more effect on gravity.
Sort of, like it's being pulled down harder.
Okay, right? And then boiling water versus the same amount in a closed container. So I was thinking about this. So you put it in a closed container, put a lid on it. If you boil it, then it should weigh more than, let's say, the same amount of water in a frozen container.
Right, but
Or I'm sorry, yeah, in a frozen.
One might argue
container,
that
frozen.
if you're boiling the water, then some of the molecules will split off and it'll weigh the same.
Well, it's because you added something.
Right.
You added energy.
Yeah. So, well, no, like it's because you add energy and then the molecules fly off into the air and then you lose a bit of mass, right? But in the end, if you were to keep all the molecules there and add energy,
that's why I said it
would weigh more. And moving objects have more. And
so if you're cooking something in a crock pot and it's sealed tightly, the stuff inside as you cook it becomes heavier.
So an object at the top of the hill will also actually weigh more because what's it? Potential energy.
Potential energy.
Yeah.
All right, cool. That's it.